Today, we are going to learn how computers see the world, not with eyes, with algorithms. For this journey, our guides will be cats. When we see a cat, our brain instantly knows what it is. But what about a computer? This is where feature extraction comes in. The computer looks for basic elements like its ears, eyes, fur, and whiskers. Algorithm measures how fluffy a cat is, the length of its whiskers, and the brightness of its eyes. To summarize, algorithms try to capture the very essence of a cat. Computer captured the cat's essence, but how do it understand its shape? Edge detection helps computers with that. A computer sees an image as a table of millions of tiny pixels. It looks for points where the color or brightness changes suddenly. That's where the cat's fur ends and the background begins. Also, that is when a line appears for the computer. When a cat enters a box, the sharp lines of the box make those edges even clearer than the soft fur. Now the computer can clearly see the cat's silhouette. Now it is the time of the magical tool that pulls all together. Convolutional neural network, as known as the CNN. This algorithm doesn't see the cat all at once. It recognizes the cat layer by layer. The first layer only sees the edges. The second layer combines these edges to form simple shapes like eyes and ears. And the final layer combines all these shapes to say, this is a cat. Actually, the algorithm thinks step by step, just like a human brain, to reach a conclusion. Now, the algorithm knows what the cat is, but how does it know where the cat is? The algorithm knows that by object detection. It scans all the pixels in the image to find the cat's location. Then it draws a virtual frame around the cat. Now, the computer knows both what the cat is and where it is. The computer knows where the cat is, but cats don't stand still. They are always moving. So how does it keep up with a moving target? With object tracking. The camera follows the cat, determines its position in every new frame, and updates the frame accordingly. This way, even if the cat leaps from one place to another, the computer never loses sight of it. This technology is used everywhere, from self-driving cars to security cameras. Sometimes a complex background can make it hard to distinguish the cat. Background subtraction is the solution for this situation. The algorithm takes a static photo of the scene and compares with every next frame. The only thing that moves is the cat. It's like lowering the curtain on a theater stage and only lighting up the actor. This technique allows the computer to analyze only the cat and ignore the unnecessary background information. There is a risk in all this learning, and it's overfitting. If I train an algorithm using only photos of my cat, the algorithm might get so used to her that it can't recognize my friend's cat. The algorithm has memorized only my cat's unique spots and whisker shape. That's why, to create a successful model, we need to train it with thousands of different cat photos. And finally, face recognition. Now the algorithm doesn't just know what a cat is, it knows which cat it is. Just like a person recognizes their cat by its face. The algorithm can now tell which cat entered the scene. It's giving the cat an identity and distinguishing it from all other cats. As you can see, for a computer to see a cat, it takes a series of complex but logical steps. These steps are not only for cats, but also for understanding the world better in every field, from autonomous cars to medical imaging.